So we're going to look at the graphs of sine to get cosecant x because cosecant is 1 over sine x, right? Remember 1 over sine x. And so first let's just kind of graph sine. Well, what is sine of 0? I like to look at my little unit circle. Sine of 0 is 0. Okay. Sine of pi is also 0. Sine of 2 pi is 0. Oh, I see. Okay. Sine of pi halves is 1. Because sine of pi halves is up here. Sine is my y value. Sine of 3 pi halves is down here. So it's -1. Okay. So we have the little snake. Goes like this. Then we're going to repeat ourselves, and it's just going to keep going. Okay. Same thing here. We're going to go the other way, but let's just verify that sine of -pi is 0. So here's -pi. My sine value is the 0. Okay. Sine of -pi halves is -1. Sine of 3 pi halves is +1, so this is going to keep going like this. It's just going to keep going. What's important to notice about here is when does this pattern repeat itself? So we start at 0. Here's my little snake. Oh, I get to 0 again, but my pattern is not repeating. Get to 0 again. Now I'm going to see it's going to be the pattern. So my period for this one goes from 0 to 2 pi. So the period of sine is 2 pi. And that also means that the period of cosecant is 2 pi. Cosecant x equals 2 pi. This is just going to be the inverse. So to get cosecant, they have a reciprocal relationship. So to get the cosecant graph, we're going to list our asymptotes. We don't have any asymptotes, but when is cosecant? When is cosecant undefined? So since this is 1 over sine x, since cosecant x is 1 over sine x, when is sine 0? Well, it's 0 at all these places right here, right? So that's going to give us asymptotes because we can't have our value 1 over sine x equal to 0. 2 pi. Okay. Oh, and also at 0, yeah. Didn't draw that very evenly. This is wider than this, but it's okay. It's okay. You guys got this. So we know what our asymptotes are, and by studying this graph of by doing the asymptotes, I can put in the inverse. So the inverse of cosecant is still going to touch this. We can actually, let's prove it. So our sine is going to be 1 over 1/2, which means it's going to be 2. Oh, wait, we're doing the pi force. So sine is going to be 1 over 1. So at pi halves for our cosecant, it's going to be 1. So pi halves is going to be 1 at 3 pi halves. 3 pi halves down here, we're going to get, it's over here, 1 over -1, which is -1. Oh, look at how it's going to hit at all these points. It's going to hit all these points. But as we go larger, we're going to reach an undefined point. So the cosecant is actually going to look like this. The opposite of everything. Okay, so we put on our asymptotes, and then it's going to hit at these same points here, but then at this points we're going to undefine. We're not going to get closer to 0. We're getting closer to undefined in the negative direction. Here we're getting closer to undefined in the positive direction. Right? So that's cosecant. And then secant is going to be the same. We're going to do the same idea, but what is the inverse of secant x is 1 over cosine x. So we're going to graph cosine first. And we can see that cosine of 0 is 1. Cosine of pi is -1. Cosine of 2 pi is +1. Okay, where are my zeros? Let's see. Cosine is never, cosine 0 at pi halves. So pi halves, I'm going to be 0 here, 3 pi. So this is going to look like this. And then get the same thing the other way. Okay, so my friend that used to teach with me, she'd call sine the snake. It started at 0 and it snaked up. And then cosine the cup, because you could, it looks like a cup, you could put liquid in it. I don't know if that helps any of you guys. So that's cotangent. So now what is secant? Secant, I'll do secant in this color right here. Secant is 1 over cosine. So again, if this black graph is cosine, wherever it is 0 is going to be an asymptote. So it's going to have an asymptote here, an asymptote here, an asymptote here. Oh, all the pi halves and the 3 pi halves. Positive and negative. All right. Now what's happening? I bet you've guessed it already. You're just going to touch at these points right here and go in the opposite direction. But let's do this. What is cosine of pi? Cosine of pi is -1. So 1 over -1 is -1. Cosine of 0 is +1. 1 over 1 is 1. And then as I get closer to pi halves, my cosecant is undefined. So it's going to go up like this. This is going to go down like this. Did I say cosecant? I meant secant. Sorry about that. All right. That is the graph of cosecant. Now, we want to try to be able to look at the graph and determine values. So, continuing with example 1, what is the cosecant? This is the graph of cosecant x, and this is the graph of secant x. So what is cosecant at pi halves? Cosecant at pi halves is right here. It's 1. Woohoo, 1. What is secant of 7 pi halves? 7 pi halves. Think about this. So 7 pi halves is the same as 3.5 pi, right? 2 goes into 7 3 times with a half left over. So I'm going to do 3 pi's. 1 pi, 2 pi, 3 pi, and then half a pi. I'm going to end up down here. So what is the value at 3 pi halves? Here's 1 pi. It's going to be right here. It's going to be 0. Oh no, it's going to be undefined. I'm looking at the gold. I'm looking at the gold graph for secant. So what is my gold graph at 3 pi halves? It is undefined. Now, how did I find that so fast? I can do it this way, 7 pi divided by 2. But also, when the pi here, or the period for sine and cosecant is 2 pi, when does this pattern repeat? You go to 0, then we get up at 0. Oh, now I'm going to start to repeat here, like this, okay? So my period is from 0 to 2 pi. So for the period for cosine is 2 pi, and same for secant. Secant is 2 pi. So notice for your trig functions, trig periods. For your trig functions, tangent and cotangent is 1 pi, but all the others, sine, cosine, I'm going to write it under here, cosecant and secant, those are all 2 pi. So if you can just remember that the periods for tangent and cotangent are pi, and then all the others are 2 pi, you'll be golden. And so we should be able to answer some questions, and we did just looking at this. You can look at the graph, or also just, I like the unit circle. In your head, you can just use the unit circle. But if you're asked to graph it, all that information comes from the unit circle. Let's do a couple more problems. Okay, let's see. Find the value for which secant theta equals 1. You probably want to see what I'm doing. Find the values for theta. So this is saying, when is secant theta equal to 1? Okay, so I could, secant is 1 over sine x. Secant x equals 1 over sine x. And when does that equal 1? Well, let's go back to my graph of secant. Secant is the golden one. When is it equal to 1? Well, it's equal to 1 at 0 right here. But why is that not the answer? Hold on. Let's do it using the unit circle. Secant theta. Secant theta is 1 over sine. Let me pause for 1 second. Okay, I'm back. Just checking on something. Why is it blurry now? Okay, so the question is, when is secant equal to 1? Yes, it's equal to 1 at 0, but remember, when does it repeat? It's going to hit up here again, because this is going to be like this. So every 2 pi, so it's 0, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Every 2 pi, because at negative pi, it's negative 1. So we're going to go 0 plus 2 pi, plus another 2 pi is 4 pi, plus another 2 pi is 6 pi. So when we ask for when is secant theta equal to 1, think of when is 1 over sine equal to 1. So we want this to equal 1. When does 1 over sine x equal 1? Well, when does sine x, I multiplied both sides by sine. When does sine x equal 1? Sine x equals 1 no, this is not right. Let's look at, why did I do the hardest one first? Secant, okay. I'm looking at the right graph, okay. At 0 and 2 pi, here we go. We're just going to look at the graph. All right, let's look at tangent, okay. Where's my tangent graph? Tangent graph, in our tangent graph, when does tangent theta equal 1? Tangent theta equals 1 at, we're getting closer and closer to 1 here, at, should be able to look right at the graph. Pause. All right, let's look at tangent theta. Tangent theta is sine theta over cosine theta. And when is it equal to 1? Well, it's equal to 1 when I look at my unit circle, whenever sine and cosine are the same. So it's going to be at pi fourths. It's going to be equal to pi fourths. It's not going to be this one on this side because it's a negative and a positive. But it would be pi fourths or 5 pi over 4, whenever the signs are the same, radical 2 over 2. You want to think about your unit circle. So when these are the same, right, it's going to be pi fourths, and it's going to be plus some number pi, like every pi value. So it's going to be here. I'll do it this one. It's going to be here. Then if I add pi, it brings me around to here. And I add another pi, it brings me here. So anytime I'm at pi fourths or 5 pi fourths, this is a positive number, 5 pi fourths. Okay, and cotangent of negative 1. When is cotangent equal to negative 1? Well, that's going to be cosine pi over sine pi, and that's going to be when they're the same, but opposite sides, opposite signs. So I'm going to think about this. It's going to be here, okay, at 3/4 pi, 3 pi over 4. Now we're going to look at the graphs of these.